Assalamu alaikum student. Today we start chapter 2 differentiation. Introduction. The ancient Greeks knew the concept of area, volume and centroid, which are related to integral calculus. Later on in 17th century, Sir Isaac Newton and Gottfried, a German mathematician, considered the problem of instantaneous rates of change. They reached independently to the invention of differential calculus. After the development of calculus, mathematics became a powerful tool for dealing with rate of change and describing the physical universe. Dependent and independent variable. In differential calculus, we mainly deal with the rate of change of a dependent variable with respect to one or more independent variable. We will first explain the terms dependent and independent variable. We have a function y is equal to f of x. F of x is the value of f at x equal to x belongs to the domain of the function. Let us consider the function f of x is equal to x square plus 1. The differential value of x belongs to d. The expression assume different values, x is equal to 1, 1.5 and 2. When I put 1 in this equation, it becomes 1 plus 1, which is equal to 2. When we put 1.5, 1.5 square plus 1, it is equal to 3.25, and when we put 2 square plus 1, it becomes 5. We see that for the change 1.5 minus 1 is equal to 0.5 in the value of x, the corresponding change in the value of y is given by value of 1.5 is 3.25 and value of 1 is 2. The change in the value of x and change in the value of 1.25, it is obvious that the change in the value of the expression depends upon the change in the value of the variable x. When we put 1.5 and when we put 1, the change in x and also change in the value of the y, x behave independently, so we call it independent variable, but the behavior of y depend on variable x, so we call it the dependent variable. The change in the value of x is called the increment of x, is denoted by the symbol delta x, and the corresponding change in the dependent variable y for the change delta x is the value of x is noted by delta y. Change in x is called delta x and change in y is called delta y. Usually the small is in the values of the variable are taken as increment of variable. In this chapter we shall discuss function of the form and is called independent variable, y is called dependent variable. Average rate of change. Suppose a particle is moving in a straight line and its position from some fixed point after time t and t1 are given by the distance traveled in the time interval where t1 is greater than t, and the difference quotient is difference in y values and difference in x values, represent the average rate of change. Distance over the time interval is not small, then the average rate of change does not represent an accurate rate of change near t. We can elaborate this idea by a moving particle in a straight line whose position in meter after t second it is given by, we have a equation t square plus t Now we construct a table for different values of t as under. We put t3 and t5 in this function t square plus t. It gives us the value when we put 5 and when we put 3. 5 square plus 5 and 3 square plus 3 divided by their difference, 5 minus 3, it gives 9. Now we put 3 and 4 and it gives the average speed is 8, and we put 3 and 3.5, it gives 7.5. We see that none of average rate of change approximate to the actual speed of the particle after 3 seconds. Now we reduce the interval. Now interval is 3 to 3.5 seconds. We first 3.1 and then 3 and then we change the interval from 3 to 3.01, more close values, and it gives 7.01 difference, and then more close to 3 and 3.001, it gives 7.001. The above table shows the average rate of change after 3 seconds approximately to 7 meter per second. As the length of the interval become very small, in other words, we can say that speed of the particle is 7 meter per second after 3 seconds. Then the different quotient becomes, because t1 is equal to t plus delta t, and delta t is like 3 to 3.001, delta t is 0.001. Now difference in the values divided by the difference in time, which represent the average rate of change, as delta t tends to 0. It means the difference more close, provided the limit exists, is called instantaneous rate of change. Now derivative of a function, if f be a real valued function continues in the interval x and x1 belongs to D domain of f, difference quotient represent the average rate of change in the value of f with respect to the change x1 minus x. The value of independent variable x approaches to x, then x1 tends to x. Provided this limit exists, is called instantaneous rate of change of f with respect to x. Now x1 is equal to x plus delta x. Then expression become x plus delta x. When we write x1 place x plus delta x, then the simplified form is delta x. Now delta x tends to 0. Provided the limit exists, is defined to be the derivative of f with respect to x at x and is noted by f dash of x. Now the domain of f dash consists of all values for which the limit exists. F is said to be differentiable at x. The process of finding f dash is called differentiation. Notation for derivative. Several notation for derivative. We used the function symbol for the derivative f, for the function y is equal to f of x, y plus delta y, change in y, and x plus delta x, where delta y is increment in y corresponding to delta x, the change in the value of x. We move y to the right hand side, and y is equal to f of x, dividing both sides, delta x. Here this y we move to the right side and we place y by f of x, divided by delta x, taking element delta x tends to 0, and this is denoted by move to delta y or delta x is equal to dy by dx, and also it can write as f dash of x is used for the derivative of y with respect to x. Here it is not a quotient of dy and dx, and dy by dx is also denoted by y dash or y prime. Now different notation by different scientists of mathematician. Leibniz used dy by dx or df over dx, Newton f of x, Lagrange f dash of x, and Cauchy capital D f of x. These are all are same, but by the difference mathematicians are the derivative of a function. If we replace x plus delta x by x and x by a, then the expression become f of x minus f of a, and it is equal to this, taking limit x tends to a, and it becomes f dash of a. Now this is called derivative of f at x is equal to a. Now to solve the questions, you remember these 4 steps. First of all, we have a function f of x. We replace f of x by x plus delta x. Then we subtract the changed value and the question value and divide by delta x, and then taking delta x tends to 0, we'll put limit when we simplify the numerator, and always we common delta x from the numerator and cut by the denominator, and then we put the limit. The method of finding derivative by this process is called differentiation by definition, ab initio, and first principle. Remember these 3 names. If we have in question differentiation by definition, ab initio, or from first principle, we use these 4 steps. Now we have a question f of x is equal to c. We replace x by delta x, and then we subtract above both these 2 equations, left from left and right from right, and then divide by delta x, taking limit because it is equal to 0. So remember that derivative of a constant value is 0. Now in another question we have x square. We replace x by delta x, then we subtract left from left and right from right, and simplify right side. We taking square, a square, b square, and 2ab, and then simplify and taking delta x common, we divide by delta x both side, and on right hand side we got delta x, and then taking limit, and this approach to f dash left hand side whole equal to f dash of x, and right hand side delta x is equal to 0, so it becomes 2x. Now here we have a question f of x is equal to square root x. We replace x plus delta x by x plus delta x, and then we subtract left from left side and right from right side, and then rationalize these values. In numerator we have a square minus b square, divide by delta x, now got this delta x, and taking limit on both sides, put delta x by 0. So add these values and it becomes 1 over 2 square root x. Now we find derivative at x is equal to a. At the end we put x by a. Now this is the complete answer. Now in this question we have y is equal to 1 over x square. We replace y by y plus delta y and x by x plus delta x. Again we subtract left from left side. Now y and y are cut each other. It is equal to delta y, and right side 1 over x plus delta x square minus 1 over x square, taking LCM, and on numerator we apply the formula a minus b and a plus b. A square minus b square is equal to a plus b and a minus b. Simplify these values, taking common delta x, and this delta x cut by this, and taking limit. And now to find the dy by dx at x equal to minus 1, we put at the end x by minus 1 and find the answer. Find the derivative of x raised to power 2 by 3. Replace x plus delta x. We subtract left hand side from left and right side from right. Now here we multiply and divide by this value. I think this is a difficult method given in the book. We solve this question by a simple way we have done in we will do in exercise. So if we continue this, then in the above we complete the formula aq minus bq. It is equal to this, then taking square on numerator and simplify and taking delta x common and divide by delta x. We got the above delta x, and then taking limit and simplify, and we get the answer. Now in this question we replace y by delta y and x by delta x, x plus delta x, and also this x by x plus delta x. Then we subtract left from left side, y minus y, it is equal to delta y, and this side minus this value. Now we simplify. Here again simplify by the difficult method, but try to simplify by simple method, taking cube, multiply and open the bracket, and at the end we have the same result. We common delta x and cut by this, and then taking limit of both side, and we get the answer. Now here again we have question y power x raised to power n. We replace y by y plus delta y and x by x plus delta x. We subtract these values, and in this form we apply binomial theorem. X raised to power n, then n minus 1 delta x, then n minus 1 2 factorial x raised to power n minus 2. We note that the power of n reduced by 1, and power of delta x, here delta x power 0, then delta x is equal to 1, and then delta x square. At the end we have the delta x raised to power n. When we open the bracket, lost xn and the first xn cut each other, and from the remaining values we take delta x common, divide by delta x, and the common delta x got by the delta x we divide, and then taking limit, all the values are equal to 0 except the first value. So we have a general formula here. If we have x raised to power n, then its answer is n x n minus 1. It means derivative of x raised to power n, we multiply by the same power and reduce its power by 1. Now same question when we take negative integer minus m means 1 over x raised to power m, and then we subtract left from left and right from right, taking LCM. Now we apply binomial the same formula on this bracket, x raised to power m, then x power m minus 1, m minus 2, delta x raised to power 0, delta x raised to power 1, delta x raised to power 2, and at the end delta x raised to power m. And the coefficients, here we have coefficient 1, here we m minus 1 over 2 factorial, and then we open the bracket, xm cut by xm, taking delta x common, this delta x cut by the delta x we divide both sides, and then taking limit, delta x tends to 0, all these values are 0 except this value m x m minus 1, and in denominator we have xm and xm. Now the power are same, base is same, the denominator x power subtract from the numerator. Now because minus m is equal to n, therefore at the end we have the same answer, n x n minus 1. Okay student, try to solve these examples. If you have any problem, then send it to me. Thank you and Jazakallah.